Hello everyone, this is Zahid Pushki. I am a faculty member at Department of Commerce, University of Gujarat, and a PhD scholar at Delhi College of Commerce, University of Punjab. Today, I am going to start the Stata training on time series analysis. Today, I will discuss some basic considerations. The participants could not join due to some reason, but as per schedule, I am I am conducting this training, so I will share the recordings with the participants without their direct participation today. Uh, First of all, I would like to discuss with you the time series framework. What are the important things that you need to consider before analyzing your time series data? So let us discuss some basic consideration regarding the time series analysis. It is a very good paper, an easy to understand paper. It will let you know the appropriate methodological framework for time series data analysis. So for analyzing your time series data, I would personally recommend that you should study this paper because it will let you know the step-by-step procedure that you need to find out for your time series analysis. So first of all, you will see a line graph here. I will let you know how to estimate your line graph. It will show you some trend, some time series trend of your relevant variable. I will let you know how you will find out. Then there are some properties of time series data that you need to understand. The first property is that your time series need to have an auto-regressive characters of time series. So a time series data may have some kind of relationship with its previous values. So this kind of model is known as auto-regressive or AR model, where where your variable may need to have the relationship with its own previous values, say lag 1, lag 2, and so on. So in case of in case of where your dependent variable is influenced with its own uh, previous value, or you can say 1 year lag value, then it is known as AR1 or autoregressive or first order autoregressive model. But if it is influenced by its previous two values, like lag 1 and lag 2, then it is known as the AR2 model or second order autoregressive model. So this is the basic characteristic of a time series model. So in addition to it, you need to understand the difference between AR process and moving average process. Beside the AR process, the moving average process model also estimate the present value of a variable based on its current and previous year error term. So it is entirely different from it. Then the second characteristic of your time series model would be whether your series is stationary or non-stationary. So this is the basic criteria that you need to understand for finalizing which model you are going to apply for your final estimation or for your hypothesis testing. So I will let you know this framework. Then there is trend, cycle, and seasonality in time series data. That is another feature that sometimes your data may follow some trend, some cycle, or some seasonality pattern in the data. So whenever you need to determine the stationarity, there are a lot of options available in Stata for considering the stationarity of your data. The first option is the augmented decoupled ADF test. that you can apply using Stata in order to see whether your data is stationary or not. Then the second option in time series analysis is Phillips Perron PP test, which you can apply in order to check the stationarity of the data. Then another option is KPSS test, Philip and KPSS test that you can apply. You can also consider the structural break in time series. That is another process that I will let you know in my upcoming sessions. Then there are a lot of things that you can consider here in time series. This is the basic framework that you can follow for considering your models. Like, for example, if all variable are stationary, you can apply OLS or bar models. If all variable are non-stationary, then either you need to apply the ARDL model or Jonassen test, where you can find out whether your variables are co-integrated or non-co-integrated. If they are co-integrated, you can consider the ECM or causality test. And if your model shows mixed stationarity, then you can apply the ARDL model. I will let you know in detail this framework because this is not an easy to understand framework, but I will let you know an easy to understand framework. So here are a lot of things in this paper. Here are a lot of details that is provided with this paper. You can see uh, different types of econometrics model here with reference to time series, like ARDL model, how to consider the ARDL model, one of the most popular model in time series analysis. I will let you know the detail of it then. Causality test, how you can determine whether there is a causal effect of your dependent and independent variable. Then you may have some diagnostic test as well in order to validate your estimations or your coefficients like goodness of fit. That is basically the R square value. Then you may have some diagnostic test that you can apply. Uh, you can consider the uh, a lot of diagnostic tests, residual diagnostic tests, uh, correlation diagnostic tests, heteroscedasticity diagnostic test, LM test, and so on. I will let you know in step-by-step procedure. So this paper basically explained the overall theoretical modeling and procedure of time series analysis. For example, here you can see the OLS model estimation, how an OLS model in time series analysis can be prepared and how it is basically uh, tested. Then you can see the ADF test, which is basically a unit root test. Here you can see there are a lot of variables which are not stationary at level. But at first difference, a number of variables are stationary. So there are a lot of methods that you can apply. But if you consider the trend and intercept, majority of the variables becomes stationary at first difference. So this is the basic criteria that you can apply uh, using the time series analysis. So this is the Phillips and Perron test, unit root test. Then this is the KPSS unit root test, comparison of different tests, what they have given the output, then bar model estimations, co-integration test detail procedure and what are their assumptions, then error correction models. Here you can see the econometrics modeling, Jonassen co-integration test results. You can see here. Then these are the co-integration results. Then you can see here basically the ARDL modeling, how to consider the ARDL model. like this. Then Granger causality test. Here it is reported. Then ARDL test output. So this paper will let you know the complete time series analysis procedure, a lot of important estimations that you can see here. You can see here the Granger causality test and their explanation. So this is the complete package. This paper is basically the complete package where you can see what kind of basically estimation you need to follow. So uh, in easy way, if we need to understand this whole procedure, I have prepared some framework that need to be followed for applying the time series analysis. So you need to understand this framework first in order to correctly applying the time series analysis procedure. So always remember, in case of time series analysis, the first and most important thing that you need to consider is the stationarity, is the unit root testing. So there are a lot of tests available for unit root, and I will let you know one by one how to estimate the unit root testing procedure. But on the basis of it, you can you can decide which model is going to be applied. For example, if your dependent variable is stationary at level and your independent variables are also stationary at level, so in that case, you are going to apply the simple regression or OLS regression. So OLS regression is basically finalized for hypothesis testing when your when the stationarity of your model shows that dependent variable is stationary at level and independent variable are also stationary at level. So in that case, you are going to apply the simple regression or OLS regression model. In the other case, if your dependent variable is not stationary at level, but it is stationary at first difference. So dvi into 1 means that your variable is stationary at first difference and your independent variables are stationary at mixed level. It means some of your IVs would be stationary at level and some of them might be stationary at first difference. So they will show the mixed stationary. In that case, when your DV is stationary at first level and your IVs are representing mixed stationary, then you are going to apply the ARDL model. Then after that, if your dependent variable is stationary at first difference and your independent variable are also stationary at first difference. In that case, you have the choice. Either you are going to apply the ARDL model or you are going to consider the Jonathan cointegration. So I would personally suggest that you should consider the ERDL model along with co-integration test. So if your variable are co-integrated, you are going to consider the vector error correction model. But if your variables are not co-integrated, it means they have no long-term relationship, then you are going to apply the vector autoregressive or VAR model. So if your dependent variable is stationary at level and independent variable is stationary at first difference, in that case, this is no model. So always remember, whenever your dependent variable is stationary at level and your independent variable is stationary at first difference, then you are not going to consider your model. You need to revise your data, whether there are some error in your data. You need to understand that in that case, you need to consider whether your data is normal or not. Maybe your data may represent some normality issue. In that case, you are going to consider some not normal procedure or some procedure with non-parametric application of time series analysis. The last thing that you need to consider is if your dependent variable is stationary at second difference. It means it is not stationary at first difference, rather it is stationary at second difference. And your independent variables are also stationary at second difference. It is the case where you are going to apply the AR model, AR2, AR1 or AR2 model. So that is autoregressive model procedure. So this is the basic framework that you need to follow for your time series analysis. So today I am going to discuss some basic considerations towards the time series analysis and some of the basic commands. I will discuss up till the stationarity testing today using Stata. Always remember when you are using the time series analysis, you are going to consider a single cross section. It means a single country, single company, single individuals, and you have a number of years, number of months, number of quarters, number of weeks, or number of days data. So you may have a single country or company. So let's suppose I am going to consider a data set, although it is a panel data, but I will convert it into some time series data for your consideration. For example, this is my Stata. I need to open the data set. Here it is a panel data set. So always remember when you are going to use the time series analysis, you may have a single country data. If it is country related data, it might be a single country data. If it is related to the companies, it may be a single company data. And if it may be related to some individual, it may be a single individual data with a number of years. So I will copy from the years to uh, the level where it basically considers only the single country. So let me let me copy the data related to just a single country, for example, Australia. I am just taking the data for Australia in order to consider it as a time series, because if I take the data for more than one country, it will become the panel. So let's suppose this is the data. I will copy this here, variable name. So now it is basically the time series data from 2000 to 2021, FDI, financial development, uncertainty, capital formation, sustainable economic growth, GDP growth rate, GDP per capita, trade openness, inflation rate, exchange rate, and real growth rate. So there are a number of variables here. So after putting your data here, the first thing that you need to consider is to declare your data set to be time series. So TS set is the basic command. Then you need to mention if you have years data, then you need to write here years. And if it is quarterly data, you need to write here quarter. And if it is monthly data, you need to write here monthly. You need to verify that what time dimension is basically given with you. So here you have years data. So what you need to write here, TS set, then years, because we have years data. So always remember that don't make any spelling mistake here. So TS set years, then comma, year. It will declare your data set to be time series, the annual time series data. So it has shown you that the data basically start from the year 2000 and ends on 2021, and it is yearly data. The next thing that you can consider is to create a line graph. So you can create a line graph by writing here line, and then you can put your any variable. For example, if I want to consider the line graph for my dependent variable, which is FDI. And then the next thing is I need to write here the time series variable name, which is years here. So I can write here years because it is my time series variable here. So it will show me the line graph of my dependent variable. So it is representing that the FDI is was basically at the highest level at the year 2004 or 2005. Then it started decreasing and recorded at its lowest level on the year 2020, and then it start improving again. So line graph will show you the data related to uh, the trend of your variable. You can also consider the trend of the other variables too. For example, line, uh, FDI, FD, uncertainty, CF. For example, these are the variables, and then years. So it will show me a combined graph, but it is not recommended because it is not showing a very good visuals. Uh, the capital formation is shown as a orange line, while the others are showing in different colors. So it will represent you the lines like this. So if you need to create your uh, uh, trends of different variables, you can use this command. Then the next thing is you can create the summary statistics of your variable, whether they are dependent or independent. You just need to write here sum, and you can put your all of your variable here in order to create the summary statistics, the important summary statistics of different variables like this. So it will show you the mean, the standard deviation, minimum and maximum, and the number of observations. So there are 22 observations here. So you can see here the average value of all the variables along with their standard deviations, minimum and maximum. The next thing that you can do is to consider the correlation analysis. It is the same commands that we have used in our simple regression analysis as well as in time series analysis. So PW correlation, then you can put your all of your variables here, then comma star 0.05 and then 6 and enter. So it will show you the Pearson correlation along with their significance results. Here you can see there are a lot of significance correlation here. So this is how you can consider the Pearson correlation in time series analysis. Then after doing this, if you want to run a simple OLS regression, the procedure is same. You can run here, or you can write here reg dependent and independent variable in the same way. This is the simple OLS regression in case of time series analysis. Because at this level, we are not sure which model is basically appropriate for our results. But here you can see the variables are insignificant here. The model is statistically fit. The R square is 72%, but the variables are not significant here. There might be some issues like normality and so on because the number of observation are just 22 and it is below the minimum criteria of normality. So the next thing that we need to consider for deciding which appropriate model we need to apply in case of time series analysis. So in order to decide that, we need to consider the stationarity. So there are a lot of things that a lot of procedure that you need to follow for unit root testing because using the unit root testing you would be able to apply uh, which is appropriate model for your estimation. So always remember IO means that the variable is stationary at level, while I1 means stationary at first difference. So whenever I write I0, it means stationary at level, and I1, it means stationary at first difference. So sometimes some of the variables are not stationary at level. So we need to create the first difference, and we need to see whether they are basically uh, stationary at first difference or not. So the hypothesis procedure is variable is not stationary. Uh, then we can consider it on the basis of the critical value. I will let you know this that how we can apply this procedure. So the first test that you can apply is augmented decoupleur test. There is a manual procedure that you can apply. You go to statistics, you go to time series, and here there are a lot of tests here. You can use any of these tests. For example, if I want to consider augmented decoupleur test, you can use any of your variable. For example, I want to consider FDI. As we have already considered the time series in years, so we don't need to select it again. You can choose from here yearly, and always remember that you need to consider the trend in the regression. So choose it and click on OK. It will show you this is the test statistic value. You need to compare this value with all other values at critical value 1%, 5%, and 10%. And if you can see, it is greater than all other values. And the p-value is also significant. So we can say that FDI is stationary at level. So it might be stationary at first difference as well. If I need to compute its stationarity at first difference, so you just need to copy this command, put it here, and before FDI, you need to put a D dot. So it will create the first difference here. So you can see here the test statistic value has increased, and it is also greater than the all other values. And here the p value is also become significant. So we can conclude here that FDI is stationary at level as well as at first difference using the augmented decoupleur command. So you can see here, this is the way that you can place the output of your variables. So this is at level and this is at first difference. So when a variable is stationary at level as well as at first difference, so you need to report like this. So this value is basically the estimated value, the value that you have seen here in the test statistic, like this. The other test that you can apply here, you go to statistic, you go to time series, and then test. Philip and Farron, which is also known as PP test. It is a very renowned test. You can use it. You can set up your time, years, yearly. It is okay. Include trend term in regression and click on OK. So it will compute your results like this. And you need to see the ZT value here. It is greater than all values of different critical levels, and p value is also significant here. So you can see it is significant at level. So if you need to create its first difference, you just need to put d dot before the variable, and it will compute its first difference. So you can see here the test statistic value, and it is greater than all other values, as well as the p-value is also stationary. So this is how you can consider the stationarity of your variable using different methods. So Tomorrow we will decide, I will decide which method is appropriate. So the time for today's session is going to end. So as there is no participant was present today, so there might be no questions from them. So tomorrow I will let you know that on the basis of unit root test, how we will decide whether we are going to use the OLS, the ARDL model, Jonassen co-integration model, no model, or autoregressive model. So I will let you know the step-by-step procedure and as well as the other important consideration for time series analysis. So thank you very much and stay blessed. See you tomorrow.